6.1. This should be a relatively quick video. For the ready, those of you who are really good at conversions, this actually might be pretty good for you. Those of you not so good with conversions, it actually is not going to be difficult stuff. It's a lot of just understanding how a clock works. So, and how things spin around and what a revolution means. First, before we start, let's talk about what angular speed is. Angular speed is how fast something goes in a circle. So revolutions per minute, per second, per hour, that's angular speed. It's how many degrees it is moving per second. So in our 1 through 3, you need to pay attention to what it's asking you to find. So in 1 and 2, they want it to be degrees per second. How many degrees is that second hand moving? How many degrees is that minute hand moving every second? So if you look at the clock when you are sitting in class watching this video, you see how it keeps moving. Well, how far is that red hand moving, that second hand? How far does it move every second? What is that degree? So they're giving us some information here. And to find the angular speed for the second hand, the angular speed is 360 degrees divided by however many minutes. Well, if I want it per minute, then it's obviously moving. Now the second hand, okay, the second hand takes takes 60 seconds to go all the way around a circle. So if I have a clock over here, here's my clock, okay, just go with it, and I have the second hand to go all the way around, it's going to take 60 seconds. So if I want what is the angular speed of that second hand in seconds, I'm going to take that there are 360 degrees in one revolution to go all the way around. It's 360 degrees, but how many seconds does it take that hand to go all the way around? It takes 60 seconds. So when we divide, we end up getting 6 degrees per second. So that's the angular speed in seconds. It's 6 degrees every second. So you can do the same thing with numbers 2 and 3. You have a little bit more work you have to do for number 2. When it says, so now we're dealing with the minute hand, and the minute hand is 360 degrees per hour, because the minute hand, it takes a whole hour to go around. Okay, but since they want it in seconds, you need to convert 1 hour into blank seconds. So you need to figure out how many seconds are in an hour. So like in number 1, we divided by 60 seconds. You're actually going to have way more seconds than that you are going to divide by. So it's always going to be 360 divided by something, but you need to convert 1 hour into how many seconds are in an hour, and then divide. For number 3, they want the angular speed of the hour hand. So think about how long does it take that hour hand. So if I go back to my clock here, and this is my hour hand, think about how long is it going to take that hand to get right back here where it started. Think about how many hours it is going to take, since they want it per hour. And then it would be 360 divided by something. So you need to figure out that something. That something is how long does it take that hour hand to go all the way around. Okay, and it's not 24. If you are thinking it
Jose
takes,
Armando
hold
Santos
on.
Montes, please report to the main office. Jose Armando Santos Montes, please report to the main office.
If you're thinking that it takes 24 hours for the hour hand to go around a 12-hour clock, think again. Okay, so that's 1 through 3. numbers 4 and 5 are actually not that bad. There's a lot of words that you might be like, what? Vinyl record, RPMs. Well, don't think too hard. Please do not think too hard with this. With angular speed, it's okay, let me start over. You have 3 different sizes of vinyl records. We have the 45s, the 33s and a third, and the 78s. And those are named based on the size of the record. The 45s are called the 45s because in 1 minute, they complete 45 revolutions. So if you were to take a record and you put a mark on that record and you click a counter every time it comes back around to that same position while it's spinning, you are going to click it 45 times in 1 minute. So that's what the RPMs is. So when I want to find the angular speed of a 45 RPM record, I want it in how many degrees is it covering in 1 minute. Well, the 45, this is revolutions per minute. Okay, revolutions per minute. So it's going around 45 times. 1 revolution is how much? 360 degrees. So I'm going to take the 45 RPMs and I'm going to multiply by 360, and that's going to give me my degrees per minute. 360 degrees in 1 revolution, and if it's spinning around 45 times, 33 and a third times, 78 times, how many 360 degrees is that? So we just need to multiply them. In the next one, we are going to start switching from angular speed to linear speed. So angular speed again is how fast it's actually turning in a circle. So many degrees per second or whatever the unit is. Linear speed is how far it is traveling. So I want the actual distance that it is moving. I want the feet. I want the degree, I don't want the degrees. So to do this, excuse me, I need to remember that circumference is 2 pi r, and since I am given the diameter of these, I'm not going to use 2 pi r. I am going to use diameter times pi. So that's going to make my life easier. So a 45 RPM record has a diameter of 7 inches. So we have different diameters for each of these records. Okay, so keep that in mind as you guys are working through this. So now, instead of how many degrees is this record turning, I want the actual distance. If I were to roll out the record that many times on a straight line, how far will I have to roll the record? So I want the circumference. That's what I'm trying to find. Circumference is the perimeter. It's the distance around. That's what I'm looking for in 1 minute. So it's 45 revolutions per minute. So for a 45 RPM record, the diameter is 7 inches. So I'm going to have 7 times pi, and it's going around 45 times. So I want 1, this represents 1 revolution, but I have 45 revolutions to make, and I don't think you want to do 7 pi 45 times, so we use our multiplication. So 7 pi times 45. That's going to give you the linear distance, okay, or linear speed. It's going to move so many feet, feet, inches, whatever, in this case inches, in so much time. So that's how you guys are going to go through and finish number 5. Okay, moving on to the set. This is going to be kind of weird because we didn't do the task, and I'm really not worried about it. I know on your paper I say go ahead and do the set. I'm not needing you guys to do the set right now. We may come back to it, so don't cross. Okay, you probably already did cross it out, but whatever. If we come back to it, we come back to it. If not, we're actually going to do this in the next homework, and I'm going to go more in depth in that one, okay? So we're going to kind of save going over that until 6.2. And then for the go, you are given one trig function, so sine, cosine, or tangent, and you are going to use that to find the other two. So you are going to need to make sure you remember SOHCAHTOA. Okay, so when I'm given sine, I know sine is opposite over hypotenuse. So I can actually make a right triangle. It doesn't have to be perfect. And if this is my theta, you can put theta on either one of these two angles. Just remember, it cannot be your right angle. But if I put theta, so opposite is 4, hypotenuse is 5. Now you can use the Pythagorean theorem to find the missing piece. Okay, you have to find the third side. So I can put x squared plus 4 squared equals 5 squared, and I'm going to end up with x squared equals 9, so x equals 3. So that missing piece is 3. So now I know my opposite, I know my hypotenuse, and I know my adjacent, so I can finish filling in this cosine and the tangent. Cosine is adjacent over hypotenuse, so my adjacent is 3, my hypotenuse is 5. Tangent is opposite over adjacent. Opposite is 4, adjacent is 3. So not that bad, but you're going to have to do that multiple times. What you need to be careful for with the tangents and the tangents are the only ones that are not fractions. You can turn those into fractions by putting a 1 under them. Okay, so don't overthink those. You still have your opposite and your adjacent. So use SOHCAHTOA, make your right triangle, use the Pythagorean theorem, and find what is missing, and then use the other two fractions for the two missing trig functions. All right, that is it for your 6.1 RSG. Go ahead and get to work on that, and if you have questions, save them for when I get back. All right, see you later.